Hey Pre-Cal, let's talk about probability. Probability comes in two sections, empirical probability or theoretical probability. And empirical probability is when you actually perform an experiment, like you take a coin and you flip it 100 times, or you take a pair of dice and you roll them 100 times, and you basically have observed events. And observed events divided by the total number of times an event actually occurred. So the empirical statistics and empirical probability actually come from observing events happening. Theoretical probability is mostly what we're going to talk about, and it is the easiest way to think about it if you think about these two questions. What I want to happen divided by what could possibly happen. That is a very easy way to think about probability in terms of theoretical probability. And notice the notation here, P of E. This is the probability of an event. That's just a shorthand way of writing that. Probability is always between 0 and 1 inclusive. You'll see this sometimes. If P of E is equal to 1, the event is certain. If P of E is equal to 0, the event will not happen. So all probabilities exist between 0 and 1 inclusively. So here's a little bit more vocab. The whole idea of a sample space. A sample space is just the set of all possible outcomes of an experiment. It's the what could possibly happen when you are computing probability. So, what is the probability of getting a sum of 5 when 2 dice are rolled? So, first of all, remember that one die is called a die, and then of course dice is plural. So, if we have 2 dice being rolled, how many different ways can we get 5? Well, one thing to consider, and you can see a nice screenshot of this on the Google site, is that rolling a pair of dice, the 2 dice are independent of each other. So what I mean by that is that a roll of 2 and a roll of 3 is different from a roll of 3 and a roll of 2, which I'll just denote as 2, 3, and 3, 2. Those are 2 different rolls. Okay, so of course we could also get a 1 and a 4, or a 4 and a 1. So those are the only ways that we can get a sum of 5 when 2 dice are rolled. So 1, 2, 3, 4. We've got 4 of what we want to happen. Well, what could happen? Well, the sample space of rolling a pair of dice is going to go from everything to 1, 1, and you can see a picture of this on the Google site, to 6, 6. So if we think about fundamental counting principles that we looked at in the last section, if we think about how many are in the sample space, well, die number 1 has 6 options, and die number 2 also has 6 options. So the sample space of rolling a pair of dice has 36 options. So what could possibly happen? 36. So what is the probability of rolling a sum of 5? It's 4 over 36, which is 1/9. 1/9 chance. And of course that as a percent would be an 11.1% chance of rolling a sum of 5 when you roll a pair of dice. So, the probability of an event not happening. So, if the probability of an event will happen plus the probability of an event it will not happen equals 1, think about that. Flipping a coin is easy to think about. You're either going to get heads or not heads. One or the other is certain. So the probability of an event will happen plus the probability that an event will not happen has to equal 1. Therefore, P of not E is simply 1 minus P of E. Some people call that the complement. So, examples. In a standard deck of cards, remember, a standard deck of cards does not include jokers. It just includes 52 cards. So, cards are either red or cards are black. So, if we want the probability of getting or if there's a probability of getting a red card that's equal to 0.5, then the probability of not getting a red card has to be 1 minus 0.5. So the probability of getting a black card is also 0.5, which makes sense because half the deck is red and half the deck is black. Here we go. If you are racing with 3 other people to lunch, then there's a 1/4 chance that you'll be first. So we're not putting any rankings here. We're either saying you're first or you're not first. So the probability that you'll be first is 1 out of 4. That means the probability that you won't be first will be 1 minus 1/4 or 3/4. That should be pretty easy for you to visualize. Probabilities of mutually exclusive events. Mutually exclusive. Think about what that means. Mutually exclusive. They are completely separate. So let's think about this. On this simple spinner, the probability of spinning a red or blue. So notice the word or here. Is there any spot on the spinner that is red and blue at the same time? Because if there was a spot that was red and blue, then they would not be mutually exclusive. But red and blue are mutually exclusive because there is no overlap. So the probability of spinning a red is 1 out of 4. The probability of spinning a blue is 1 out of 4. So to get the probability of spinning a red or a blue, we're going to add those two probabilities together. 1/4 plus 1/4 equals 2/4, 1/2, 50%. Red and blue sections are mutually exclusive. So let's look at something that's not mutually exclusive here. So what is the probability of selecting a card from a standard deck of cards that is red or a face card? Now, we're still using the word or, so we are going to be adding here, but let's answer these questions. How many cards are red? Well, if the deck is 52, 52 divided by 2 is 26. So there are 26 red cards in the deck. How many cards have a face? Remember, face cards are only jacks, queens, and kings, not aces. So 4 plus 4 plus 4, there are 12 face cards in the deck. But there's some overlap here because it's not mutually exclusive to be red or a face. There are some cards in the deck that are red and have a face on them. So what are they? Well, it's the jack, queen, and king of hearts and the jack, queen, king of diamonds. So 3 plus 3, there are 6 cards in the deck that have a face and are red. So what we have to think about here, so what's the probability? Well, first of all, what is the probability of selecting a card? So we're only choosing one card, so that's going to be out of what could happen. What could happen in a standard deck of cards is 52. All right, and we are after the probability of getting a red or a face. So what do we have to do? Well, we've got 26 that are red. We've got 12 that have a face, but we have 6 that are red and have a face. So we have to take the intersection of these two events away, the things that are not mutually exclusive. So 26 plus 6, 32 out of 52. 32 out of 52, and that would be, as a percentage, 32 divided by 52. So that is approximately a 61.5% chance of being dealt a card from a standard deck of cards that is red or has a face. That's a pretty good probability. So here we go again. In a certain board game, a player spins a color spinner and rolls a die, a six-sided die. The events are mutually exclusive. And yeah, I've got a strong glare because I have a very technologically advanced slide here. Woo, now you can see it a little bit better. So these events are mutually exclusive, but they are successive. So these are events that are happening one right after the other. So let's read the problem. What is the probability that a player will roll a 4 on the die and spin a red? So things that are successive and mutually exclusive, we're just going to multiply them together. So the probability of getting a 4, remember the die has 6 sides, all equally likely. The 4 is one option out of the 6. The spinner has 4, so one option out of the 4, so 1/6 times 1/4, 1/24, or 0.042. So that would be a 4.2% chance of rolling a 4 on the die and spinning a red. They're mutually exclusive of each other, but they are successive events. So that is what you need to know about probability. Very quickly, one more time. This I wanted to bring back. Probability, theoretical probability, always ask these two questions. What do I want to happen? Divided by what could possibly happen. Answering these two questions are going to help you get through the homework with ease.